Hello, so in today's video we are going to go through balancing equations. So I've got one on the board and I'm going to try and balance it to show you how we do it. It's really important, it's a skill that is in a lot of the topics, so it's really important for us to be able to do this. First thing I always do is put a dotted line between the products and the reactants, and that allows me to really make sure that both sides are balanced, because the aim of balancing an equation is for the same number of hydrogens or H's on this side as on this side, and also the same number of iodine or I's on both sides of that arrow. So it's almost like a seesaw that you're trying to balance out so that there's the same amount of elements on this side as there are this side, so it doesn't kind of drop to one side. So what I do is I draw a line in the middle and then I write H equals I equals, and that's just allowing me to work out how many H's I've got on this side of the arrow. So how many H's in the reactants? Well, there's 2, because that little 2 means it's multiplying by the number, the element directly in front of it, so it's 2 times H, so it would be 2. Also 2 times I, so that would be 2. On this side we can also do H equals and I equals. How many H's? Well, there's no numbers around it, which means that it's just 1. No numbers around the I either, so that's 1. So we've started off, we've set ourselves up well, that we've got it all set up so we know how many of elements on either side. We know it's not balanced, because if it was balanced, the H's would both have 2 and the I's would both have 2. They would need to be balanced with each other. So we know that these two both need to have to double to be able to get there. Now when you are balancing, this is a key problem. I often see students adding numbers in here and here. You can only add numbers when you're balancing equations in the front of the compound or element. You cannot put it in between, it changes it all together. So what you can do is you can put a number here, here or here. At the minute they've all just got 1s in front of them, so you wouldn't need to ever write 1 in front of them, and the number in front would multiply these numbers by that. So if I want to double this, I want to put a 2 in front of here, because then 2 times 1, because remember there's just that means there's 1 if there's no number after it. 2 times 1 would be 2, so H equals 2, which means that's balanced because the same number of hydrogens as reactants and products. Take that one. 2 times I as well, because that 2 is everything after it before there's another plus. So 2 times what was 1 is also 2. If we just check, I on this side is 2, I on this side is 2, so that is a balanced equation. I'll do another example to show you the basics, and then I'll give you a chance to have a go at doing these yourself. Okay, so I've just written on the board another example of an equation that needs to be balanced. So first thing I did last time was just separate the reactants from the products by drawing a dotted line, and then I wrote out each element. So we've got Na equals, and we've got Cl equals, so sodium and chlorine. There's no number around that Na, so that means it's 1. The Cl, there is a number after it, which means it's multiplied by that, so it's 2. There's 2 Cl. Na on this side, and then we've also got Cl. Na equals 1, Cl equals 1. So we need to be balancing this. And the first one I'm going to try and balance is this bit down here, because the Cl is 2, and the Cl over here as the product is only 1, so it's half. Now, I said you can only put numbers in front of these elements and compounds. You cannot put numbers in the middle or after anything. It has to be in front when you are balancing. So what I would do is I would put a 2 here, because that would mean that when 2 times the 1 of the Cl, that would make us get 2 Cl. And that would balance the Cl's, because at the beginning and the end they're now both 2. However, that number in front of the Na has also changed the Na. It's gone from being Na equals 1 to Na equals 2. And unfortunately now our NAs are no longer balanced. The way we can balance it is we can only put numbers in front of any compounds. So which compound or which area of this equation would we want to put a number in front of? It'd be right here, so that we can balance the reactant Na up to the same as that one. So if I put a 2 there, that now becomes 2 because 2 times 1 is 2. Na on the left hand side, the reactants is 2. Na on the right hand side, products is 2. So 2 and 2 is balanced. That's how we balance that one. That was a little bit more difficult. What I'd like you to do this time is, rather than just watch the video and watch me do it, I'd like you to pause the video and write this in a piece of paper or anywhere you've got. Write out the equation, have a go at the steps I've done. So separate the reactants and products. Work out how many on the left of the hydrogens and the fluorines and how many on the right of the hydrogens and fluorines, and try and balance it. So pause the video and then I'll go through the answers. Okay, so you should have paused the video and you should have an answer in your books or on a piece of paper now. I'm going to put my line between the two. I'm going to write H equals 2 because there's a 2 after it, so it means it's multiplied by. F equals 2 because there's a 2 after it, so it means it's multiplied by 2. H on this side and F on this side. H equals, well, there's no numbers around it, so that must be 1, and F is also the same. There's no numbers around it, so it must be 1. So we obviously need to balance this. It's not balanced at the minute because there's 2 on the left hand side of hydrogens, there's only 1 on the right. There's 2 on the left hand side for fluorine and only 1 on the right. Now I can only put numbers in front. Can't put numbers after, can't put numbers in middle of compounds. I can only put them in front of any of these. And in this case, I want to be multiplying this up. I want to double these. So I would put a 2 in front of there. That would make the hydrogen equal 2, and this fluorine also equal 2. Hydrogens on the left, 2. Hydrogens on the right, 2. Fluorine in the reactants is 2. Fluorine in the products is also 2. Balanced. Check your answers. Mark anything that wasn't right. Tick anything that was right. Okay, so there's a little bit more challenging version, but I'd like you to pause the video and have a go at balancing this equation. So you should now have had a chance to balance the equation. First step, dots down the middle just to separate the reactants from the products. Then I write H equals, H is going to equal 2 because that's the number that's near it. O equals 2. And then H on this side equals 2 and O equals 1 because it's the number that's either, there is no number after it and there's no number in front of the whole compound. That 2 there is only for the H. So that means that hydrogen equals 1. So it's obvious that the hydrogens are balanced actually at this point, so we can tick them, they're balanced. Oxygens are not balanced, and before you do this or before you think you've got it right, you cannot put the 2 there. I've always said in the video the 2 has to go, or the number that you are going to multiply it by has to go in front of any of the compounds on the board. So it has to go in front, and if you put a 2 there, that makes it something different. It makes it hydrogen peroxide, so actually you've changed the whole reaction itself. So you need to put a number in front. There's only half the amount of oxygens as there is here, so I would put a 2. That makes this 2, so that's balanced. However, now your hydrogens, 2 times 2 equals 4, so that's no longer balanced. We're going to have to go over to the left hand side because this one's double that one now, so we need to try and work this one out. You need to double the hydrogen number, so you can only put the number in front, so you put a 2 in front, which would make that 4, and that would make that balanced. So that was a little bit more challenging. We'll do one more example and then we'll Okay, so final example, I'd like you to pause the video and have a go at balancing this. This one is a little bit more challenging. So you should now have had paused it and have an answer in your book of your balanced equation for this one. I've already drawn the lines in between to separate the reactants and products. Fe equals 2 because there's a 2 after it. Oxygen equals 2 because there's a 2 after it. This side, Fe equals 2 because there's a 2 after it. Equals 2. O equals 3. So this one's a little bit challenging because it's not just double the number and it's not just half the number. The oxygens aren't balanced. On one side there's 2 and the other side there's 3. Now I don't often like having odd numbers in the equations. I find it easier if we double this up, we can get an even number and then it's easier to be working out where everything is. So I like to always put, if there's an odd number, I always like to double it and put a 2 in front. Like we say, we can only put numbers in front of the compounds or elements. So if I put a 2 there, I've gone up to 6, which is a lot of oxygens, and Fe, 2 times 2 is 4. So I've got 4 ions. So now I've got quite big numbers, but I think it's easier to work out how to balance both sides, because here the Fe is just double. So I can easily put a 2 in front, because we only put numbers in front, and make that 4. So the Fe's are now balanced with 4 on the right and the left hand side. Oxygens are a little bit more difficult, but if I did 6 divided by 2, I'd get 3. So if I put a 3 there, 3 times 2 would give me 6, and that would balance them. So I always like to double odd numbers. That's just personal preference. To be able to then work out, I found it much easier to balance the Fe's because it was then just double. And then the oxygens, to balance them, it was using the common denominator and trying to work it out. So that is a harder, challenging one to do. So I hope you've enjoyed the video. That's a quick one of explaining how you balance equations.